laptop hybrid will not be very effective. You need camera and the sound system, proper camera and sound system, without which it will not work.
Yeah. I think gradually it will come. Anybody from outside also they can join, and from anywhere in the world they can come over. They can
So
give
that in any case, online, like the meeting which we are conducting, the lecture which we are just now conducting, anywhere in the world it is possible. But if you want to have a hybrid one, the arrangement in the hall.
Okay, we will. Pardon my saying,
yes,
sir.
Good evening, sir.
Good evening. I think we will talk about it another day. Let's concentrate on today's function today. And so therefore, I think 3-4 persons are here. And then there was Sahu. I can see he has the pin there. Professor Sahu is there. Again, namaskar.
Yes, sir.
Namaskar. Madhyo, namaskar.
Namaskar, sir.
Pleasure meeting you. So we have, so this is your grand student speaking today, Professor Sahu. So one of your grand students somewhere in the world. So therefore,
it's always a pleasure to hear all these people.
Yes. It is necessary because they are the people who are the torch bearers of the great tradition that you have set in. And therefore, how they are taking it forward is something which you would love to know. And I think they are taking it forward well, hopefully. But we are grateful to you, sir, that you are attending ritually. You have made it a point to, in the midst of your very busy schedule, to attend the SGAT's meeting. So that's very nice. And
thank you very much.
This is one part. And whether your friends from Canada will join today, I do not know. But I think Professor Mr. Girija Mahapatra has
I think somebody from abroad has joined. The name Naitha Mere. It appears whether he's from India or abroad, not very clear. Neitha, Naitha Mere.
So would you please introduce yourself, whoever joined from abroad?
Not very sure.
So somebody will. There are 9 participants, so some of them will definitely. Professor Alene. So there is a minute-to-minute program that you have prepared, Alok Babu and Girija Babu.
Yes, sir.
So we.
Mr. Sujit will be anchoring. He will be joining shortly.
Acha, he will anchor.
Yes, Sujit will be.
And so finally, Dr. Farooq.
Dr. Farooq will be moderator.
The moderator, provided he has his connections. Girija Babu, like me, we have apprehensions about his connectivity from his place.
Yeah, so, it's okay now.
Oh, Dr. Farooq.
Yeah, good
evening. Also joined.
Namaskar, everybody.
Namaskar.
Name is not appearing in the list.
Hello.
No, he is on a pseudonym.
No. Actually, that is my first initial name, Badruddin Mohammed Farooq.
Oh, Badruddin name.
Yeah.
Actually, this name has been inserted by Debashish, I think, not me.
I
think.
Okay.
Lovely. You look splendid.
Okay, he's there. He's there. He's in the top list. Okay.
Let's say he's there and he looks absolutely splendid. And why not?
Thank you.
Today. So I was telling Dr. Farooq to Professor K.C. Sahu.
Yeah.
Professor Sahu, this is a grand student speaking today.
Oh, yes. Grand student.
Yeah.
So this is what
Professor Mulugeta is grand student, right?
Yeah. Alene Mulugeta.
His name is.
What thing Mulugeta to start on time?
Huh?
I said to start on time is the most important thing. And now it is 21, another 9 minutes.
We still have 9 minutes, sir.
So we'll start in 9 minutes. So, so that's that.
Sukumaran sir, I think good evening. It is GP Mahapatra here.
Dada, bolon.
Dr. Sukumaran is from which place?
তার মানে ওই আমি
Kumaran
যেটা
is from Kerala.
হুম,
I think Mangalore.
সেটাই
No, not the town I'm asking, which organization?
He was in Geological Survey of India.
Oh, he's a GSI person.
J.K. Nanda is also from GSI. He has also
Sujit has joined.
Sujit has come.
না ওর নিচে
And
যে
our
লিংকটা আছে ওটাকে
PN Naik sir, I think he is there from GSI. He is a very expert in the geophysics.
তার মানে আমার না তার মানে আপনার ফোনে জুম নেই। আচ্ছা ঠিক আছে, আমি দেখি যদি পরে কিছু হয় আপনাকে দেখাবো।
Good evening, sir.
Good evening, good evening.
না ওরকম হবে না, ওটা ডাউনলোড করতে হবে।
Sujit Babu, you are happy that you have,
দ্যাট
because yesterday we missed you in the meeting.
Sir, I was not there.
No, that's okay. That's okay. No, but you have been able
we
to
have
come today.
started because we are organizing it.
So Sujit Babu, are
we
you
are already in the
in
meeting.
Bhubaneswar or somewhere else?
I am in Bhubaneswar, sir, today.
That is only no. That is because
I am at home.
Dr. Farooq, I think you have to mute yourself.
Yes.
So that when the others, when they join, they are not confused and they don't hear anything. It's better. We don't have Professor Sahu, something like a national anthem or anthem for our society. whoever comes, he listens to the SGAT anthem. No, we don't have anything like that. Neither do we contemplate to have one. But that's how the other societies, wherever there is such a thing as what you call the society's emblem, musical emblem, shall we call it? And so that comes into play. But that's not the case here. So that's that. So we have so far 11 participants only, just 11. That includes Devasis, which means there are 10 people. We are not surprised that another 7 minutes people will come. In Bengali, they have a very nice statement. You might recall from your Kharagpur days. Stage mere debo. So I don't need to do anything beforehand. So I will come to the stage and make it stage mere debo. So this is what in Kolkata, even in Kharagpur, our students used to say. কিছু করবো না সারা বছর বসে থাকবো then স্টেজে মেরে দেবো so this is the Indian typical psyche. But I'm surprised, Gejau, our speaker should have been informed to come at least 10 minutes before.
Yes, sir.
He is available now. As per the
Is he?
Yeah,
He's there already.
Oh, yes, he has joined. He has joined. Yes.
So
Yes,
Professor
joined.
Mulugeta,
Yes, he has joined. Professor has joined.
Professor Mulugeta, if you are there, then a hearty welcome to you and good evening in India. And you are probably 2 hours behind or thereabout.
It's good afternoon there. Our good evening.
Yes, for him it is good afternoon.
It is good afternoon for me. Yes,
Yeah.
it is
Namaskar, namaskar.
4 p.m.
Exactly, that's what I was trying to say.
Yeah.
4 p.m. So today, did you have your classes and you have finished your classes or Saturdays are off?
Normally, Saturdays are no classes on Saturday and Sunday.
Right.
But I am also on sabbatical. Anyway, I don't have a course engagement at the moment.
Okay. That's right.
I'm on sabbatical. I was supposed to move around, but because of a number of reasons, I'm still in Addis.
Yes.
I was supposed to go to Japan, October and November. But Japan is closed for visitors because of COVID.
Okay.
So I couldn't visit Japan this year. Perhaps I will go next year. So yeah, maybe next plan is to go to United States in a few months. But I'm here in Addis, no courses. I was only preparing my talk, my presentation, so I had enough time to prepare.
Excellent. By the way,
Yes.
we have amongst us who are present already one of our extremely eminent professors of geosciences is Professor K.C. Sahu from IIT Bombay, and he is very much present here. He did Namaskar, as you possibly saw him. Professor Sahu is a very eminent. He's speaking. He is actually present from Bombay. IIT Bombay. He has for many years. He has retired. So I told Professor Sahu before you came, I said to him that your grand student is going to speak today, assuming that from Professor K.C. Sahu to Professor Dr. Farooq is one step, one generation down, and from Dr. Farooq to Dr. Mulugeta is another generation practically. So therefore, you are the grand student of Professor K.C. Sahu. Professor K.C. Sahu was one of our speakers also, DLS speakers earlier on.
Okay, good.
Hopefully there'll be some.
Incidentally, I have my 5th or 6th generation of PhDs.
Oh,
Wow.
You'll be surprised.
I didn't get that, Professor Sahu. Would
I
you kindly?
have got the 5th or 6th generation of PhD. My students.
Oh, I see. I see. Oh, 5th generation, you said.
Of
Okay.
PhD. Yeah.
Very good. So one millionth, you can say the 1 millionth student. Okay. So that's a part per million kind of thing. Your PPM student. I think in short you would say your PPM student. Yes.
Yes.
Okay. Now today, I don't know. It is only 2 minutes and the participants are only 22. So as soon as we touch 30, we start. That's one way. As soon as we touch 18:30, we start. So we will start at 18:30, I would imagine. Which means
Yes, better.
And the others will join.
Yes, sir. We will start in time. Others will join definitely.
1 minute more. So we
are the computer timing same for everyone?
Yeah, so we meet. Yes, it is same.
Hi, Mule.
My brother has joined us also.
Oh, great.
He's a civil engineer by profession.
Yes.
And I'm sitting in the office. He's following this lecture from his home. But this is his office.
Okay.
Okay.
Yeah.
So
Good afternoon, everyone.
Good afternoon. Very good afternoon.
Very good afternoon.
Great to see you all.
So you're very nice seeing you, and you have a very nice plant inside your room. How often do you have to take it outside in order to feed it on the sunshine? How often?
Thank you. Yeah, sorry?
Every 7th day,
Yeah.
you take out the potted plant outside?
Yeah, once in a couple of weeks is enough, I think. It's indoor plants. Yeah.
It's an indoor plant. Okay. So
yeah.
So Sujit, I think it's time. Yes.
Yeah, we can start now. Yeah.
You can start and people will join. I'm sure people will join.
Yeah, very good evening and warm welcome to all the distinguished participants and our esteemed speaker of this evening, Dr. Mulugeta Alene, Associate Professor, School of Earth Science, Addis Ababa University, Ethiopia, and Adjunct Associate Professor, Department of, just a minute. Adjunct Professor in Department of Department of Earth, Environment and Planetary Sciences, Case Western Reserve University, US. I'm sorry, USA. So very warm welcome to our esteemed speakers, in particular Dr. Alene, and myself, Sujit Mohanty, and the member of the Executive Council of Society of Geoscientists and Allied Technologists, aptly known as SGAT. SGAT is a non-profit making professional body dedicated to the promotion of mineral development activities in India in general and in Odisha in particular. This society started in the year 1980, and it has members representing disciplines of geosciences, particularly geology, geophysics, mining engineering, metallurgy, environmental engineering, process control engineering, and allied disciplines. This distinguished lecture series, which is known as DLS, is one of the flagship programs, activities of the society, of our society, which is intended to bring for the dissemination of knowledge and information among all the fraternity, particularly of geoscience, metallurgy, and mining engineering disciplines among themselves. So we conduct these activities bi-monthly. This is a bi-monthly activity, and this is the 5th one in a row. And with this, I would now invite our esteemed President, Professor Onkar Nath Mohanty, to please deliver the welcome address. Professor Mohanty, please.
On mute, yes. So good evening, everyone present here, and good afternoon to our friends from the African continent. And I'm quite sure there'll be some more who are going to join from the American continent as well. So I join my colleague, Mr. Sujit Mohanty, in welcoming our distinguished speaker this evening, Professor Mulugeta Alene from Addis Ababa, and his colleague, Dr. Bedasa, and Professor K.C. Sahu from IIT Bombay, who has graduated, but he's a distinguished professor. In addition to that, there are a number of colleagues from SGAT and others outside SGAT. So welcome to everyone. And as Sujit has said already, that this is a distinguished lecture series, which is one of the flagship activities of the society. But most important thing is that we always would like to see that the societies such as the Society for Geoscientists and the Allied Technologies, they are not the silos which operate in isolation, but today any discipline one can talk of or think of in order to deliver the kind of expectations that are entrusted to it, it cannot work only as a silo. Therefore, it has to essentially with a number of disciplines. And that's very important today, and which is why the Society for Geoscientists and Allied Technologies thought of it quite some years back and thought that many other disciplines also must come into the picture, which is why the geoscientists and then the mining engineers, mineral beneficiation, metallurgical engineers who are the extraction engineers and extraction in itself, and therefore people like me, for example, we utilize the metals and alloys and other materials in actual components such as automotives and so on, and we are all together. And when you talk of environment along with this, it makes it complete because that actually goes across all disciplines. So we are indeed pleased that the DLS 5, as you call it, this is the Distinguished Lecture Series number 5, and which is going to start now. And we are all looking forward to what we expect to be an exciting and fascinating lecture by Professor Mulugeta. And we had great experience and pleasure day before yesterday, also meeting him on a trial run. And through the trial run, we came to know that Professor Mulugeta is not an unfamiliar name to the community of geoscientists in India. For example, in this very community where we were gathered today, Professor Dr. Farooq is there, who was one of the senior colleagues of Dr. Mulugeta. As a matter of fact, he started his career in the geoscience with Dr. Farooq, who is one of our members here. He is present here, I'm so pleased. And then there'll be others also who would have known Dr. Mulugeta. One of them was the president, one of our earlier presidents, Professor Acharya, Satyananda Acharya, who is no more with us. And Professor Acharya also spent years at Addis Ababa and with and Dr. Mulugeta also spent time with them. Therefore, he has seen Indian geoscientists, and our community also knows Dr. Mulugeta. And therefore, it's a double pleasure that we have Dr. Mulugeta Alene in our midst. I therefore have great pleasure in welcoming you, Professor Alene, in our midst and towards the lecture. Thank you for coming over. Sujit, take over now. You have to unmute yourself, Sujit.
Thank you very much, sir. Now, I would request our esteemed Vice President, Mr. Girija Prasad Mahapatra, to kindly introduce our esteemed speaker of this evening to all the participants. Mr. Mahapatra, please.
Thank you, Dr. Sujit, and all the participants, all audience here. Good evening and good afternoon to all of you. So I have the pleasure to introduce Mr. Mulugeta Alene. Because of the thrilling subject, which is volcanism, tectonics, and hominin evolution in the Afar Rift, East Africa. It is really a challenging subject for all of us, probably, because volcanism is there, tectonics is there, and the evolution of this one. And so therefore, it will be very interesting to listen to Professor Mulugeta. So let me have the pleasure to introduce him also. Mulugeta Alene, he had his BSc degree in geology in 1984 from Addis Ababa University, Ethiopia. Followed by he had his MPhil in 1991 from the University of Southampton, United Kingdom, and PhD in geology in 1999 from the University of Turin and University of Genoa, Italy.
Can you please, all of you, mute yourself so that there is no echo?
In 1984 to 1988, he was deployed as the graduate assistant and assistant lecturer in the Asmara University. From 1991 to 1995, he was a lecturer in Addis Ababa University and assistant professor, School of Earth Science in Addis Ababa University. 2008 to 2010, associated dean of the science faculty of the same. And since 2011, he is the adjunct associate professor, Case Western Reserve University, United States of America. And 2012 to 2020, graduate program coordinator of the School of Earth Science, Addis Ababa University. And besides this one, he has associated with number of associations and erudite institutions. He is the co-founder and member, African Rift Valley Research Consortium since September 13, 2013. Earth Science Curriculum Review member at Addis Ababa University since 2002, and also for other 4 universities. He is the chairman of the National Task Group for Geology, Curriculum Development, Harmonization in Ethiopia 2009, Executive Council member of Ethiopian Geoscience and Mineral Engineering Association 2008 to 2012, and some training and local communities on community-based ecosystem tourism development of Adwa Tiger, Ethiopia, in collaboration with Institution of Development Research, Addis Ababa University. And he has nearly overly 40 peer-reviewed articles and book chapter and monographs. Professor Mulugeta's work on hominidity in the adjoining site was published in Nature. And East African Rift Valley is the largest coastal rift valley, as you are aware, which is active in a part of the Red Sea Rift. Probably it will be this interesting subject. And apart from the stone, he is doing extensive work on the hominid evolutions, climate change, and rifting, volcanism, everything in the Afar East Africa. So definitely it is going to be all for us an interesting subject and challenging subject for us. So let us hear from Professor Mulugeta Alene. And thank you all. This is the only brief of this one. And we will be waiting to listen to Professor Mulugeta, please.
Thank you, Mr. Mahapatra. Before I formally invite Dr. Alene to make the presentation. Just I have a small announcement for all the participants. Wherever any questions are there or any doubts are there, so all are free to send their questions to the chat box only. That those can be dealt with after the deliberation is over. Now it's my great pleasure to invite Dr. Alene to make presentation. Please, Dr. Alene, please.
Thank you, Mr. Mohanty, for the invitation, and also thank you, Mr. Mohapatra, for the introduction. I'm pleased to be with you, and let me share my screen. All right, visible?
Yes, it's visible.
All right, thank you.
Yes, yes.
All right, thank you again. So as has been said in the introduction, for over 10 years, I've been working with the colleagues from the United States, from Europe, and also from Ethiopia, of course, on the geology of Afar. Before that, my research interest has been on the Precambrian metamorphic terrain, mapping deformational structures, ductile deformational structures. I'm also, of course, involved in teaching structural geology, metamorphic petrology, and geologic mapping courses. But since 2008 and 2009, I get involved with this group of geologists and paleoanthropologists who are working in the Afar region. And I started to appreciate the remarkable geology of this region. So a few months ago, a former colleague and mentor, Dr. Farouk, as has been mentioned in the introduction, he asked me if I could deliver a lecture on the work I'm doing in Afar to an Indian audience, an audience with diverse specialization, technologists and geologists. It's a bit challenging, but I accepted the request with pleasure. So here I am to talk about the geology of Afar in relation with human evolution. So my topic focused on 4 sections. The first one is simply to show you a few slides to introduce you to the Afar region, what is special about Afar. But the focus of this discussion would be on the continental rifting, rift basin sedimentation, and then finally, human evolution and Afar geology connection. So maybe most of the time will be more technical. I ask the audience to bear with me. If it's too much technical, I will always try to remind myself to be broad and suitable to the general audience. So here, this satellite image shows the Horn of Africa and Afar. This is Afar. Largely it's in Ethiopia, but partly it's also in Somalia, in Djibouti, and in Eritrea. So what is special about this region? Well, to start with, this Afar region is a triple junction of 3 rifts: the Gulf of Aden rift, the Red Sea rift, and the main Ethiopian rift. Apparently, this junction is, though it's a junction that is above sea level. Most rift junctions elsewhere in the world are below the ocean water or seawater, whereas in Afar we have features similar to that of the ocean, sea, but not covered with water. And here, this Afar and the main Ethiopian rift is the northern tip of the greater, even larger, East African rift system. So on this slide, we see this magnificent structure, the East African rift system that starts from Afar all the way south to Mozambique. The length is roughly 3,000 to 4,000 kilometers. The structure, the rift structure, is fascinating by itself. And yet, we have other interesting aspects. Here, we see again in this rift system, it is spotted with several old and recent volcanoes, and also modern and ancient lakes, all dotted along the Rift Valley. Again, more interestingly, this area is also contains sites of paleontological interest. Those dots, white dots, are hominin sites in the East African Rift system. But today's lecture or talk is on the Afar Rift. So let's look more closer on the Afar and partly also in the Ethiopian Rift. So here, this is again the satellite image on the left, but on the right, we have this digital elevation model that shows the division of the Afar Rift into northern, east central, southern Afar based on the fracture lineaments, orientation of the fracture lineaments within Afar. I added this west central Afar because that is also our focus of interest for the later discussion. So what I show you here is prominent volcanoes. Here are the prominent volcanoes, not all, but the volcanoes, quaternary volcanoes, and at the same time, we have also active volcanoes in this Afar region. Another interesting thing about this, these are to show you some of the active volcanoes in the northern part of the Afar Rift, but also in this spot where we call it Dalo, it is a place below sea level, 120 meters below sea level. It is otherworldly, one can say. It has spectacular and colorful features full of minerals. For the benefit of the people on the mineral deposit, mineral exploration people, I may say a few words if there is enough time towards the end. But this is also another spot, interesting part of the Afar in Dalo. So those spots, volcanoes we saw in the earlier slide, are all concentrated on these spots, red spots. They are called quaternary magmatic segments. They are segments. Most of these active volcanoes, quaternary volcanoes, are concentrated, but they are also, all these initial patterns, they are eruptive centers and zones of dense faulting and dike intrusions. Because of this, they are considered as incipient seafloor spreading segments within the continental mass, continental land, but incipient seafloor spreading centers. And these are fault structures on the east part of the Afar Rift. Another aspect interesting about this, as part of this introduction to the Afar region, is its fossils, hominin fossils. The one on the right shows hominin species distributed through time. Of course, there are about 6 colors, different colors, but we can safely say they can group it into 6 major hominin genera. That's called, in the dark green, genus Adipeticus. Bear with me, those names, we'll be talking about them repeatedly. Those in orange and the brown, they are genus Australopithecus. And this cyan, blue, and red are genus Homo. So 3 important genera known, almost all known hominin species in the world. What is interesting, the ones that are circled in red are all found in Afar Rift, concentrated along this area. These are abbreviations of research sites, project sites. There are DK is DKK, GN is Gona, HD Hadar, and so on. When they are on the west central part of Afar, we also call them Lower Awash Valley, and this one is Middle Awash because there is a river called Awash here that flows from highland, Ethiopian highland, all the way to Lake Abba. So most of these hominin sites are Lower Awash Valley or Middle Awash Valley, and as you can see, covering most of this time in the picture we saw in the right. The last slide I show you as introductory to the Afar region is this one. Here are 2 figures that show the human migration out of East Africa during Pleistocene. What we see here if you search in the Google, you will see and search human migration. Almost all human migration out of Africa will show you the first migration, be it 200,000 years ago or 60, 70,000 years ago, they all start from East Africa, particularly from Afar. So we can say this Afar region is characterized by, it has rift junction above sea level with plenty of active volcanoes and extensional faults. The lithosphere in Afar is in the final stage of rupture and the beginning of seafloor spreading on land, mind you, not covered by water. This Afar region again contains one of the lowest places. In fact, near Djibouti, one of them is 155 meters below sea level. The second lowest place in the world, next to the Dead Sea Desert, which is much higher. And those lowest places, Dalul and another point called Lake Assal, they have extraordinary conditions. In fact, they are comparable to Martian environment. People are studying about those areas. Most importantly, all major hominin genera, the ones I mentioned earlier, genus Ardipithecus, genus Australopithecus, genus Homo, are discovered in Afar. And as you can see from this picture, from this slide, human ancestors migrated out of Africa, out of East Africa, out of Afar. So the question is, what is the connection between this volcanism, rifting, basin development, and human origin? So to try to look at this, or to analyze this question, or to try to answer the question, let's go back to Oligocene. Oligocene is, for those of you maybe not familiar, it is an epoch roughly around 31 million years ago. So what happened in Oligocene? Interestingly, the African plate has been quiet for a long period of time, stable. Not only the Horn of Africa or East Africa, but the entire plate, lithospheric plate of Africa, remained stable since the end of the so-called East African orogeny in Neoproterozoic. Hundreds of millions of years ago, quiet and stable. And then 30 million years ago, something happened. An uprising, upwelling mantle brought huge amount of magma and erupted huge volume of flood basalt, covering large part of Ethiopia and even Yemen. In large part of this, as you can see here, the dark part is covering large part of the Ethiopian plateau is covered by these flood basalts, and also in Yemen. Between those two dark places is Afar. So this huge volcanic eruption happened 31 million years ago. Either it has been buried below younger materials or completely obliterated because of subsequent deformation and magmatism. So before we look at this deformation and magmatism since the Oligocene time, I want to show you a few pictures to appreciate this huge volcanic eruption. Here you have in the plateau over 2,000 meter thickness, covering large part of Ethiopia. So this A, B, C are here. This is from this point, and this one is from the northern tip here in the Ethiopian plateau. What we see here are sections showing the thickness, to appreciate the thickness. In fact, they are called LT, HT, which refers to low titanium, high titanium division, geochemical division of these huge rocks. Huge rocks erupted in Oligocene. And I would say comparable to the Deccan Trap in India. The Deccan Trap erupted in Cretaceous much earlier, but this one is only 30 million years ago that erupted and covered. So what happened after this? Well, since Oligocene, nothing remains quiet in Africa. particularly in East Africa. Nothing remained stable, nothing remained quiet. Dramatic events, geological events start to happen. So here what we have is the African lithosphere, including the Arabian plate, start to stretch, to extend and thin as a result of two major forces or stresses. One is because of the rising plume we mentioned earlier, which was also responsible for the eruption of this huge volcano. But also the plate has been pulled northward towards a certain subduction zone here. It is called the Zagros orogenic front, a subduction zone as a consequence of the closure of the Tethys Ocean in the Oligocene and Miocene time. The closure of that pulled the lithosphere. So this reinforces the pull, the slab pull, and also the rising plume, reinforce it, to stretch, and to, in fact, rupture it. As we see it here in this picture, along the Red Sea, we have the formation of oceanic crust. So the lithosphere break up in the Gulf of Aden and in the Red Sea. Whereas in the Afar, it is thinned, extended, widespread faulting and rifting is taking place, and yet it's not yet in the full oceanic crest formation. We call it a transitional between. It has lost its continental character, but it is acquiring an oceanic character, and we call it a transitional one. So this is the model, the plume, it's also called Afar plume, impinging on the Afro-Arabian lithosphere, producing this red is the one we call this 2,000 meter thick flood basalts, geochemically two groups, low titanium plateau and high titanium plateau, depending whether the source is from the core part or from the outer part. We have these two divisions. And this one shows the pre-rift flood basalts in Ethiopia and Yemen. And then towards late Miocene, the initiation, the activation of major boundary or rifting occurred, starting from late Miocene. Here is a complete rift evolution, starting from pre-rift flood basalt, and then please note those times, 11 to 2 million years ago, the activation of faults, boundary faults or rifting, and then around 2 million years ago, beginning of Quaternary, a shift of deformation, a shift in the location of faulting as well as in the orientation of faulting. As you can see on the right side, the older late Miocene faults are northeast trending, whereas the newer ones, the shifting of deformation, are northeast trending. So these are zones of maximum concentration of strain and also magmatism in the recent time. And this is mainly a large part of the main here, MER, North Main Ethiopian Rift and Southern Afar. But in the Central Afar, something else happened as well. This is to show you what happened to the Central Afar. In Central Afar, those old rifts from the Red Sea and the Gulf of Aden start to propagate. So four things happened in Central Afar and partly in Northern Afar. One, the propagation of the rifts from the Gulf of Aden towards northwest direction, from Red Sea in the southeast direction. That is one thing. The second, as a result of this rift propagation, another phase of fissural rifts, fissural basalt eruption. We call them this, maybe we call it olive color or something. This dark part is the Afar stratoids that erupted in the Pleistocene time. And at the same time, northwest trending major grabens and horsts also formed within this time as a consequence of this propagation. And lastly, as you may probably see those gray spots over here, they are quaternary magmatic segments where you have recently the strain, the deformation, magmatism being focused or concentrated. So here we have almost the same one, except the color changes from the quaternary magmatic segments became dark, shown as dark, and the color is changed. But what we are interested here is this block diagram showing the pattern of those magmatic segments, the initial pattern in which a lot of magmatism and a lot of deformation, the localization of strain, we call it, is happening, which is similar to what is happening in the spreading, seafloor spreading centers. So this magma injection or dike intrusion weakens further or facilitates the stretch, the extension, and the rifting. In fact, if I show you here, there are models that show two types of continental or lithospheric stretching. This one, tectonic stretching. Here, a stretching assisted with magma. When there is magma intrusion or magma injection into the lithosphere, it weakens and it can easily be extended, faulted, rifted. So what we have here is a contour map of more depth. So the Afar shows very thin. The crustal thickness is in the range of 20 to 25 kilometer depth. So magma injection, extension, deformation, thinning the Afar rift, and facilitating further rifting, further deformation of the Afar lithosphere. So for the first part of section, we can summarize those pointers. Around 31 to 30 million years ago, there has been continental flood basalt eruption. Then, since 28 million years, the rifting in Gulf of Aden and Red Sea occurred because that of the main Ethiopian rift, Afar rift, didn't start until late Miocene. That is around 10 to 11 million years ago. By then, activation of north-east trending large boundary faults happened in northern main Ethiopian rift. Sorry for the repeated abbreviation, and in southern Afar. But also, within this range, as I mentioned earlier, there has been rift propagations that were responsible for the formation of huge gravens and holsts in central Afar. And of course, also for the widespread fissure eruptions in the Afar stratoids within this time range. And since 2 million years ago, we have this narrowing of the rifting, the localization. As we have mentioned, those initial magmatic segments, and these are the consequence of weakening of the lithosphere and the initiation of ocean basin in Afar. So let's go to the second topic, which is rift basin and sedimentation. This is a detailed geologic map of the Afar area, but we don't need really those detailed geologic map of. So what I did is simplify into this one, so that within the Afar we have three important rock units. The green one is the Pleistocene volcanics, and the white one, were also numbered here near this the river we mentioned, Afar, Awash, sorry, are Pleistocene sediments. And then the red ones are the quaternary magmatic segments. Most of the hominin fossils are concentrated along those Pleistocene, these white patches. And these are, the numbers are hominin fossil sites. We will be talking about them in the later part of the discussion. So now we are going to see sedimentary sequences of a certain selected sites in the West Central Afar. Here we have representative sections from areas called Mille Logia, Waranso Mille, Hadar, Gona. These are areas, fossil sites in Afar, and showing sedimentary sequence, variable thickness from around 100 meters in Mille Logia, and as high as 600 meters in the area called Gona. And these sedimentary sequences are interfingered with basalts. These colors are to show the location of basalt interfingering with the sediments. Here, the names are abbreviated here. But most importantly, we have also other thin layers here. They are volcanic ashes, tuffs. These are everywhere we see them, here, here, here. They are vital because those ashes contain important minerals that are useful for dating. So to constrain the age of the sediments and the fossils within, we employ argon-argon dating in order to know the age. Many geologists spent long time in the field and in the lab studying those sections. So they became one of the best studied, documented, and dated sequences. If not in the world, certainly in Ethiopia. So what do we have? What are these? These are the sections that show oscillation of fluvial and lacustrine depositional environments. To show you some pictures from the field here, this is called Hadar Formation. This is Gusidima Formation, an unconformity between them. This Gusidima, as you see, it are gravel, silt, sands, and the Hadar is largely lacustrine silt. This is from the place called Gona, whereas this is from Hadar. This is particularly important because it is this formation, the Hadar formation in Hadar, that where the famous fossil Lucy has been found. Now, what we see in this vertical section is the thickness variation. Those layers, those sedimentary sequences, they seem to show variation in thickness. For instance, the upper one seems to thicken towards the west, which is the Gusidima formation, the type of rock formation. We find it in the West Central Afar. And the lower one here, the Hadar formation and older formations, they seem to thicken towards east. And this variation in thickness has been controlled by fault. So they thicken towards where there is this boundary fault. Those group working in Gona propose this model to show the control of faults and basin geometry and thickness variation of the rock layers. So here in the earlier part of, in the lower section of the unit, strata, isolated, disconnected faults with small basin. Later, when these faults join, the basin grow and sedimentation increases, and these sediments thicken towards the fault. Here, eastward thickening, also here, eastward thickening, whereas here, a younger fault developed in the west side. So the younger rock, which we call it Gusidima formation, starts to thicken towards west. So here we see the very much control of fault within the rift system and defining the geometry of the basin. These are rift models, rift evolution models. What we have here is typically early state in the initiation of rifting. You have small faults, small displacement magnitude, small basin, disconnected. But when this get connected or linked, the basin grow, fault magnitude increases, eventually became larger, and large basins or lakes form. So maybe I to just save time, I may skip this part. But basically, this is to show how variation in the boundary fault displacement defines the geometry of basin, thereby the nature of basin sedimentation or basin deposition. Maybe here we have a model, rift basin models. When a basin is forming, oh, sorry, what happened? a basin created because the crust thinned and subside, and then followed by sediment fill or water fill. So depending on the sediment supply and the capacity of the basin, either you have lake or no lake. So like in early rifting, is it only for me? I see some lines over here, or also for you. I don't know what happened here, but I see some yellow lines on top of the figure. Hopefully it is clean in your side, from your part. Anyway, what we see here
the
is,
lines are there. The lines are there, but you can ignore them and go ahead.
all right, thank you. So basically, what we see from rift basins model is that early rifting, where you have disconnected faults, there tends to be fluvial sedimentation, whereas when the mature rifts grows, we have lacustrine deposition. So in a way, relative to climate, tectonics plays an important role in determining the nature of basin deposition, thereby also the local environment on long time scales. This is a point I mentioned earlier. I don't know if I'm doing doing good in time. This is while we are talking about the rift basin, we may say a few things about the Dalur area for the benefit of people who are interested on the mineral exploration. This is the Dalur area on the northern part of the Afar. It is a north-northwest trending graben. It has over 1 meter thick salt strata. It largely halite, but it has also potash salt. As I said, mentioned earlier, it has spectacular morphological features, colorful mineral deposits. Due to a complex interaction among hydrothermal alterations, sulfuric hot springs, fumaroles, geysers, and acid supersaline pools. And people are very much interested in studying because they don't seem to sustain life, and they are comparing them with a planetary terrestrial analog because of it's hot inside and on the surface is hot environment, but most importantly, extremely acidic natural system, hypersaline surface waters, and geothermal fluids. And because of those things, they are scientifically interesting, but also from mineral deposits they are uninteresting. So I will show you a few pictures before I pass to the next section. So these are the different pictures we have. The Dalur halite salt plain, and here is a pool, hot spring on the salt lake. People use salt blocks as table salt. Very huge area. When we say the salt plain, it's something like about 60 kilometer long, 20 kilometer wide area. These are hydrothermal mounds and active hot springs in the area. Acid lake with salt depositions, and these are different colors as a result of the level of oxidation. The more oxidized, they become darker or brownish. The less oxidized, yellows. These are very interesting from the people interested on the evaporitis. Anyway, we can summarize this rift basin and sedimentation as follows. The Plio-Pleistocene units consist mostly of fluviatile, lacustrine, deltaic sediments, and paleosols. Grabens have grabens served as depot centers of the geometry of depot centers. They are geometry defined by variation in the boundary fault displacements. So we can say the relationship between basin growth capacity and sediment supply within this basin environment determines whether sedimentation is fluvial or lacustrine. Okay, whether it is river fed or lake area, and that means also control on the local environment. As an additional point here, the Plio-Pleistocene, I've already mentioned that, in the West Central Afar contain abundant hominin fossils. So let's look at those hominin fossils in this part of the world. The last section of the topic is Afar and hominin evolution. So I was mentioning hominin several times so far, but what is the definition or the difference between hominid and hominin? Hominid, all modern and extinct great apes. It includes modern humans, chimpanzees, gorillas, orangutans, and their immediate ancestors. But when we say hominin, it only means modern humans and the immediate ancestors, but include those three important genera, the species members of the genera Homo, Australopithecus, Ardipithecus. So hominin, in essence, a taxonomic term, refers to tribe. So hominin contains those three important major genera, Homo, Australopithecus, and Ardipithecus. It has been nowadays well established that we, the Homo sapiens, our immediate ancestors are the Australopithecus, Afarensis or Anamensis. And this Australopithecus, Anamensis or Afarensis are descendants from the genus Ardipithecus. And fossils of all these species are discovered in Afar. Hominids appeared on Earth since late Miocene. Paleoanthropologists agree that at least there are 4 important features that define hominins based on their tools, culture, brain size, and bipedalism. On this picture, we see that this split from the last common ancestor, they call it, took place in late Miocene, around 7 million years ago. The hominin lineage here, and the rest split differently. So this walking upright is considered as the most defining feature of hominins. And it has happened also something between 7 to 5 million years ago, which is also considered as the time when hominins split off from the knuckle-walking African apes. So I want you to note this. In Afar, in late Miocene, we have said the formation of the triple junction. In mid-late Pliocene, eruption of Afar stratoid series. And then in Quaternary, localization of volcano-tectonic activity. So those times, late Miocene around 10 million years ago, mid to late Pliocene 4 to 2 million years ago, and then since 2 million years, Quaternary, we have those important geological episodes. And what happens to the hominin evolution during those times? Well, first, bipedalism. It is typical of the hominins, according to paleoanthropologists, but the difference between those 3 different genera is that Ardipithecus moved on 4 legs and adapted for tree climbing, but capable of walking on 2 legs. Whereas those species under this genus Australopithecus, they are adapted for both 4-legged and 2-legged walking. They are called facultative habitual biped. The Homo, including Homo sapiens, walks upright on 2 legs, and whereas Australopithecus are habitual biped, Homos are obligate biped. Now, where are these fossils found in Afar? Well, the diversity, representation, co-occurrence, and abundance in Afar is very remarkable. Here are the Ardipithecus distribution. In the middle, Awash, river Awash here, also in the upper and the lower Awash. Also, those fossils that belong to the genus Australopithecus, we find also in the middle Awash and the lower Awash. Again, the Homo species, the species under the genus Homo, they are also found in this West Central Afar. And these are not, again, exhaustive lists or locations. Just give you an idea, the abundance and the diversity within this Afar Rift region. This is a list again. Fossils, cranium fossils, tooth or dentognatic fossils, postcranial bones other than the skull, from the Homo, from the Australopithecus, and from the Ardipithecus are found. All these lists are in Afar. Again, I admit this is few examples we have. I managed to collect of the fossil discovery in Afar. And just to show you some of them, these ones are tooth and bones from the earliest one from Middle Awash called the Ardipithecus cadaba. This is the famous Ardipithecus ramides, 4.4 million years old, again from Middle Awash, but also postcranial fossils, another one from the lower Awash, from Gona. And then this one is from, this says WM Waransomile, a 3.8 old Australopithecus ananensis skull. Another one, postcranial fossil from, again from Waransomile, 3.6 million years old, Australopithecus afarensis. Another one, 3.5 million years old, Australopithecus dirameda, again from Waransomile. And then you have here a skull of a child called Salam from a place called Dikika, not far from those areas in Lower Awash Valley. And this one is the famous Lucy from Hadar, 3.2 million years old. And this one, another Australopithecus Gari from Middle Awash. And this one is 2.3 million years old from the genus Homo habilis from Hadar. This one, another species from the genus Homo erectus, roughly 1.5 million years old from Gona. And then this one from the Pleistocene. Here it says Homo bodensis from Middle Awash in West Central Afar. This one is Homo sapiens, again from Middle Awash. All this we have is to show you the abundance and the diversity in this part of the world. So when we look at the sedimentary, their distribution, their position within this selected areas from the lower Awash, we see that we have all from the Homo, from the Australopithecus, and from the Ardipithecus distributed in those different project sites. What I want you to look at here is the diversity, the co-occurrence, and the timing. Here, this is the beginning of this oldest Ardipithecus ramides at around, in the late Miocene, around 5.6 million years ago. But again, at around 4 million, because this is the time in million years. So the horizontal line is simply to show the diversity, the variation in type of species. But those arrows here to indicate the co-occurrence of either multiple species, in some cases like this one and this one, multiple genera at a given time. The same is with this another diagram here. The beginning of the appearance of the earliest hominin, and then co-occurrence, multiple species at around 4 million years ago, at around 3.5, at around 2.5 million years ago, and also at around 1.5 million years ago. This is what we have, the diversity and the co-occurrence. And so timing. In late Miocene, we have Ardipithecus. Mid to late Paleocene, we have the Australopithecus. And since early Pleistocene, as you have seen several fossils from the genus Homo. Just to give you some clue, again, to compare with the other countries in Kenya, Tanzania, and South Africa. Also, again, this list is not really exhaustive, but it gives some sort of clue. We see that those from Ethiopia seems to cover a wider time range in here. I admit it's not exhaustive for all, for Ethiopia, Kenya, Tanzania, or South Africa, but as it is, we see a wide range coverage in that of Ethiopia. So this is the last slide I am going to show you from King and Bailey, who showed that a complex topography, complex landscape, as you see it here, this schematic diagram, it shows active rift, normal faults, escarpments, uplifted terrain, volcanoes, lava flows, gorges, flat plains, lakes, what have you. All variation of landscapes across a given time. And they point out that this must have impacted hominin evolution. Okay, so here in Afar region, in this East African region, there are many hominin species from all major hominin genera. Multiple hominin species co-occur roughly at around those times, 4 million, 3.5 million, 2.5 million years ago, and also 1.6 to 1.5 million years ago. The hominin evolution, that is appearance of new species or co-occurrence of species, appears to coincide with major tectonovolcanic episodes in Afar. So is this coincidence, or it has something to do? There is a real connection. I leave that with you, the answer for that question, and the conclusion. Here you have.
You are not audible, Dr. Alene?
Yeah, I just leave it to you to read the conclusions.
Okay.
Instead of reading it out, he's deliberately leaving it to the audience.
Okay.
And read it and then make their own conclusion. There's no need to read it out.
Yeah, okay.
You have done the right thing, yes. I think everyone has read it now.
Yeah.
So,
absolutely.
Thank you for listening. And if there are any questions, welcome.
Yeah, heartiest congratulations, Dr. Alene, for a brilliant presentation. And you have
Thank
addressed very, three key geological processes like volcanism, tectonism, and evolution of hominin fossils.
Mhm.
And that too in one region, that is Afar Rift of East Africa. So now I would request Dr. B.M. Farooq, who will act as the moderator. He is a very senior member of our Executive Council of the Society, and he will moderate the question and answer session. So before I hand over to Dr. Farooq, I would just request Dr. Farooq one thing, that if there are not enough questions in the chat box, he can also take some questions from the participants up front. Dr. Farooq, please.
Thank you, Mr. Mahanti. Good evening to every participant, and thank you, Dr. Mulugeta, for an excellent presentation. I was simply absorbed in listening to you because certain things, I remembered when I had been reading some literature during my stay in Ethiopia. So one thing is very inquisitive, I will be very inquisitive about is the, that episode when the Lowell depression, the Lowell part of the northern part of Afar depression was part of.
Can we close this PPT?
Hello?
That will be better, I think. This PPT is too open.
Yeah, I can. Dr.
Yeah, now it's better.
Yeah, Dr. Mulugeta, can we have the overall map of Ethiopia with Afar depression just on the screen?
The overall.
Is
okay,
it possible?
Right. Sure. Let me.
Yes,
because yeah, we can when we take the questions, it will be handy.
Yeah. Okay.
To refer to the locations and all that.
This one.
Maybe yeah, I think that is also good enough. Yes.
Or the other one I showed in the slide. Maybe
yes, in the earlier one of the earlier slides.
Maybe okay. Maybe you wanted this one. This. Are you looking at this or
No,
the first one? Because this is only dull.
No, I think
even the broader one,
where,
a macro.
where you have got the Ethiopian Rift also part of Ethiopian Rift and
Okay.
Gulf of Eden. I mean total regional picture.
A total picture so that the joint also is shown.
Which one is that?
Which is almost there at the beginning.
Yeah, I think this one on the top.
The introductory of Afar.
Yeah.
So somewhere there, yes.
Next one or the next one?
Yeah.
Yeah, even this is good enough. Yes, this is good enough.
Which one? This one.
No, I think the previous one will be still better. I think.
That's
this
right.
one.
Okay.
Yeah, one above.
One above. One above is this.
Okay, this is also this one.
Okay, yeah.
This before I take the questions, I would like to tell you something and listen to you also. We have, if I remember correctly, because I read the literature 30 years ago, we have this Danakil Alps, we call it, which is also a block. It is a block mountain, which is it is a host, isn't it? And
yes, you're right.
Yeah, and this before this came up, Red Sea actually was had inundated this part of Afar depression, where we have because of which we have the evaporites, the sylvite, the gypsum, and the salt. I think all these evaporites are due to because this was the part of Red Sea, in fact, and this was the part of Red Sea, and because of the uplift of this host, which is known as Danakil Alps. In the older literature I've read is as Alps, Danakil Alps. Because of the uplift, this part got separated from Red Sea, main ocean, and the saline lacustrine condition here was actually, so it was not just overnight that the Danakil Alps came up, the separation took place. It took several thousands of lakhs of years to actually separate, and in the process repeated flooding and repeated evaporation took place here, which has given rise to huge thick deposits of salt, which includes sylvite. Sylvite is one of the most important component of these deposits.
Right.
And then we have got you have already covered the volcanics part of it. And
Yes.
this is the Awash Valley where we have the hominin findings here. And I think that's all. We will now take this question. There is a compliment from Khurshid Ahmed. Wonderful, comprehensive talk. I will not go into actually now. Okay, next is from Dr. VP Mishra. There is a question, Dr. Mulugeta. Hominins evolved. One sec. Hominins evolved and developed in the tectonically very active Afar.
Right.
Is it due to that the volcanic activity provided ultimately fertile land suited for dense vegetation and prolific animal taxa? The hominins evolved. Also, perhaps migration between mammalian taxa during Miocene, Pleistocene. Quite a big question, Dr. Mulugeta.
Yes. Yeah, thank you.
Yeah.
I would like to lean to the factor, the geology factor.
Okay.
Of course, on the hominin evolution, is it the climate, the driving force, or the land, the lithosphere, the geology? So, because what I tried to, in my presentation, I was emphasizing from the very beginning what is unique about Afar. So you don't find nowhere in the world where you have rift on the land, a junction on the land. And this huge East African rift system, by the way, this is hominin evolution is not only in Afar, as we probably know, it's also in Kenya, in Tanzania, and South Africa. But all these countries, Tanzania, Kenya, Ethiopia, and Afar, are within the East African rift system, the longest rift system in the world. So, is it a coincidence, or it has a very strong control of this geology, the rift? So I was trying to show how different this Afar triple junction or Afar depression is different from, even different from Kenya and from Tanzania in a way, because of the triple junction. There is no triple junction in Afar, in Kenya, Tanzania, and there is no transitional lithosphere between oceanic crust and continental crust. And the lowest point in Africa is within Afar, if not in the world, because a land not covered by water and yet below sea level. And then, most importantly, because of the global tectonic plate configurations, with this play of the Red Sea, the extension, the rifting, and the magmatism within this area must have played a great deal on the human evolution, hominin evolution. So, yes, the role of climate is there, because it seems from, clearly I'm not an anthropologist, I'm a geologist, but what I understand is the Ardipithecus were mostly habiting woodland, forest area. And then towards Australopithecus and towards Homo, the area became savanna, grassland. So this transition from forest to grassland has definitely, the climate has to play there. But my last slide, if you recall, let me go there, is to also give emphasis not only on the climate, but this mosaic of environment. The distinctive topographic features in the rift basin must have played a great role in driving forward the human evolution. So in long time scale, the role of geology, tectonics is very important. In shorter time scale, the role of climate is very important. So these two factors reinforce one another. It make, as you can see it from this conclusion, the last part, hominin fossil discoveries in Afar cover from around 6 million years to present, making the region truly the cradle of humankind. So you have all necessary ingredients for the diversity and evolution of hominin when you consider a rift environment. Variation in landscape, variation in topography, because those landscape and topography variation also control on the local environment, the ecosystem. So you have lakes, freshwater, you have highlands, you have volcanoes, you have lavas, you have restricted. The Kipuka, for instance, is, or Kapuka from the Hawaii, the term came from the Hawaii island. It means a restricted area, isolated because of volcanic eruptions. They isolate an area and it has its own habitat, unique habitat. So all these ingredients around the Rift Basin must have played an important role in determining the fate of our ancestors, would be my answer. I hope I addressed the question. Dr. Farooq.
Yeah. Thank you, Dr. Mulugeta, and thank you, Dr. VP Mishra. I'm sure you are there listening to Dr. Mulugeta's explanation. That's very interesting. Now we come to another question from Mr. R.N. Sar, retired Deputy Director General of Geological Survey of India. He has started with a compliment to you, Dr. Mulugeta. So to save time, I will go to that question. And also I will have to do a little bit of editing of the question, making it only, relevant to the topic. So as far as it is possible, as I understand, I'm quoting Mr. Arensar's question. As I understand from literature and from your classic talk, humans came into existence in early to middle Pliocene warm period. This transition, across which atmospheric CO2 concentration increased to levels similar to present day. Firstly, how much you support the idea that the recent global warming is exclusively anthropogenic? I think, no, Mr. Sir, it has already been established that the global warming had been taking place with the, from the middle of peak of the last glacial cycle. 18,000 years ago, since then, global warming has taken place. So that is a natural way. And it has already established that anthropogenic factor came only during the Industrial Revolution, from the Industrial Revolution, which is taken as 1850 as the cutoff date. I think that is already established very well. So we don't have to worry about the, global warming prior to that. That was natural due to the end of the glacial cycle, or when it was after the last glacial maxima, global warming took over. I think only this one. Secondly, how much you feel present day active volcanoes, particularly the East African rift system, responsible to global warming? Now this one, Dr. Mulugeta.
Yeah. Well, the scale of eruption I showed you in the earlier part of my slide. Let me go back.
Yeah, please.
Yeah. In here, these are, for instance, if you see here, this is a felsic eruption around 15 years ago. And this is 14 years, 12 years ago, again from this area. So these are not huge volcanic eruptions. These are episodic. Locally, maybe they have some sort of hazard implications, but if you look at this one, this very good looking, this beautiful lava lake is before 2017. Now you don't see the lava lake, it looks like dormant. So all in all, the contribution of volcanic eruptions in this rift system within this time range is, I would say, less significant compared to those greenhouse effects coming from the industries, I would say. That's my answer.
Well, thank you, Dr. Mulugeta. I agree with you.
Yeah.
And then he's also asking, he doesn't stop there. This is his third question from Mr. Aaron, sir. What is the next species of Homo sapiens? That is, we are not having any. And this is,
yeah, I will show. A diagram, perhaps, if it's.
No, this is something we cannot. We cannot discuss about it right now. However,
I will show him. Maybe it will answer the question. So, where was it? I thought I had it here. Sorry. I was to show a robot. Here.
Can I add one line?
Yeah.
Actually, long back, I had read from that when there was illustrated weekly, there was an article. The next species will be Homo sapiens aquaticus, because once everything is underwater, man has to move to the sea.
Okay.
That was a Russian concept.
Yeah, I would be happy to have a link of that paper. I would happy to read that one.
It is not a paper actually. I had seen an article in the long back in Illustrated Weekly. That was
all right.
popular magazine in India.
I got it. Okay. All right.
Here's Mr. Aaron, sir, speaking to you. Okay, we thank you, Dr. Mulugeta, and thank you, Mr. Aaron, sir. Now we go to the next question. Is Dr. Khurshid Ahmed. His question is, my question is with regard to flora, especially figs. I want a concordance or sort of relationship between fig fruit and evolution of hominid. Probably Ethiopia still holds some signature related to this fruit. I think this fruit is one of the oldest one, which might be of some interest for future research pursuits. Thanks.
Yeah,
I think there's a combination of biblical fig of Adam Eve.
But I wouldn't know. I don't know the answer to that question.
This is more of a philosophy. I think a combination of from the scripture to the science. No, we will talk about science here. Again, I think Dr. VP Mishra has actually thanked you for answering his first question. Now I will would like to add something, or before I add a question to you.
All right.
I was actually going through some literature, and then I found that you have done some. I think it is done by, in fact, Professor Beverly. She is also associated with you from United States of America, and she has done this tephrostratigraphy. Tephrostratigraphy is a very interesting, subject or a science.
This is Beverly Saylor. Professor Beverly Saylor.
Yeah.
Okay.
Maybe someday we would like to listen to such studies related to tephrostratigraphy, because we have here tephra deposits here in our state. Like we have got deposits from volcanic ash coming from all the way from Indonesia. Toba ash of 75-year BP, 75,000 years BP, which has come and deposited in the quaternary sediments. So this tephra, this is because it is an isolated deposit from Toba volcanic ashes coming from Indonesia have deposited in the, at least we have in Orissa, there are some places in Eastern India. So I was fascinated by this tephra stratigraphy, which could help us also in doing our studies. So maybe in future we can have this kind of deliberation with Professor Beverly. I will be very keen to know that, to listen to that. And another thing which I have now seen is that you have found that lacustrine sediment. Lacustrine sediment in the Hadar and also your Warren's Mille area.
Yes.
Right? And also there is a reference to migration of the basin, northward migration of the basin, which is, I mean, migration of this basin, Hadar, this Afar basin, shall I call it?
Right.
Yeah, that is very interesting. And then what kind of sediments you get in this lacustrine? Because I think there are marine, is it of marine origin? Or a mix of both fluviatile and marine? No,
they are
fluviatile and lacustrine only.
On the slides, I showed you this. Usually, mostly they are fluvial and lacustrine lake deposits, and also deltaic are also there. And these are most of the time they have these clay stones. As part of this lacustrine deposits. But diatomites are also there. So diatomites are also within, in Waranso-Mille and elsewhere in this lower Awash, there are also diatomites showing relatively deeper.
So that means it has a marine component.
Well,
with diatomites, how do you?
Yeah, they call them deep lake deposition, and not as such marine, because this Hadar basin is like I showed you one of the slides. Several modern lakes are abundant within the East African Rift system. So, similar to that, the Hadar basin must have also been shrinking and expanding and moving at different time, but largely lake basin.
Okay.
That's my understanding.
Okay, thank you so much. And I think if you have from the audience here, if there is anybody who is interested to put a question, otherwise I think we are almost going to the closing time, and we may have to. Yeah, please, Professor Sahu. Please, if you have a question, please, you can speak.
Yes, please. Just this
very pointed question in the interest of time.
It may be a theoretical question. You know, when I look into the Rift Valley, Rift system, especially the northeast side of this Ethiopian Rift Valleys, it appears to be getting fragmented. And with recent volcanism, extensive recent volcanism and other disturbances, is it possible or is it likely that a fraction of a land can slip into the Arabian Sea by any chance, in which case the amount of water it will displace in Arabian Sea may be so tremendous that the Indian tsunamis in Indian coast, or all the Dubai development of the sea colonies will have a fantastic effect. As such, recently reports have appeared that there have been large cracks in the lift valleys, along the lift valleys, which shows that the rift system is still active and likely to be active in near future, in which case a slipping out of a land mass from the Ethiopian regions, northeastern regions, into the Arabian Sea may create a fantastic tsunamis not known in the history of geological history at all. Doctor, Professor, can you give a remark on this?
Okay. Let me show another. This one. So this doesn't show the entire rift system, but it shows the Afar. What we have here is those arrows indicate the plate motion in the northeast direction. It's happening now 15 millimeter per year. It's extending. In this direction, 6 millimeter per year is extending. So the rate of extension motion is much higher in the northeast direction within the Red Sea and Gulf of Aden, but limited, only 6 millimeter per year. Partly this is because there is a compression coming from, because in the Indian Ocean ridge, there is a compression is coming and limiting the opening around this Ethiopian rift.
Right.
So this is happening right now. But your question about a land splitting and joining the Arabian Sea, Sea, are you referring to in geologic time scale? If it is, we're talking about geologic time scale, in the future, in million years of time, yes, this part, we call it the Somalian plate. In fact, some people also refer to this Indian plate as well, because before the India was split away, joined the Asia, probably part of within the Gondwana were the same anyway. Most consider this part Somalian plate. Like if I show you the bigger here. So the Somalian plate, the Nubian plate, and the Arabian plate. So at the moment, it is active and they are moving away. So this is the future ocean here. But we're talking about geologic time scale. But if you're talking about tsunami happening, splitting a land, joining the Arabian Sea, no, that is, human scale is quite different from the, as you know, obviously, from the geologic time scale. Did I address your question?
But we have it in the Himalayas. We are having this shaking in the Himalayas, although it is moving. As per the lecture given by the Dr. Shailesh Naik, the Indian plate, Indian continent is moving 5 or 6 times than the 6 millimeter.
Yeah.
So naturally, it can have a pull instead of a push, which you have shown. The movement of Indian plate, Indian subcontinent, is 5 or 6 times than the normal movement of the continental drift. Any plate, which may pull.
I'm sorry. I'm sorry if I'm intervening.
No,
very interesting discussion that is already developing in this lecture. But in the interest of time, perhaps we're going to bring it to a close now. So, Professor Sam, I will kind of seek apologies and your indulgence. So that yes, we have listened to Professor Alene and also to Professor Sahu. Probably there is a scope for a lot of discussion, which has to happen another day, and we will we'll try to make it happen. Very interesting topic.
Okay.
Please proceed, Professor Dr. Farooq, if you have some more questions, and then or else pass it back to Mr. Shujit.
Yeah, no, I'll just wrap it up. I will close it with just one observation. I'm going to quote one sentence from, if you have come across Yuval Noah Harari. He's an author, historian from Israel, who has written a book named Sapiens. In this book, he has given a scientific, he's a historian though, he has given a scientific analysis of the, development of human, but this one is with a little satire. The cradle of humanity continued to nurture numerous new species such as Homo rudolfensis. Man from Lake Rudolfo, you know that Lake Rudolfo is further to in the, I think, Kenyan region, Lake Rudolfo. So man from Lake Rudolfo, then Homo ergaster, the working man. It is the translation, the name given to the sapien I mean the Homo ergaster is the working man, and eventually our own species today, which we have immodestly, that is the satire, immodestly, we have named it Homo sapiens, the wise man. But here we have actually Harari calls it, immodesty to call ourselves wise man. But here I'm not doing it to myself. I'm speaking about the speaker today. We had a wonderful lecture today from a wise man, Homo sapiens from Ethiopia. Thank you so much, Professor Dr. Mulugeta. It was a wonderful, wonderful talk. We will look forward to listening to you next.
My pleasure.
Now,
Thank you so much.
Thank you. Thank
over
you so much.
to Mr. Mahanti.
Thank you so much, Dr. Farooq, also for nicely moderating and interacting. And you have made the discussions very lively. And also my special thanks goes to Dr. Alene for nicely and effectively answering all the questions. And moreover, all the participants who have participated in these interactions, I am really grateful and thankful to each of them, including Dr. K.C. Sahu, Professor K.C. Sahu rather. Now, I would request our President, Professor Mohanty, to just share his mind and thoughts, very broad observation on the discussion on the topic that has been delivered this evening. Professor Mohanty, please.
Once again, good evening, everyone, and thank you, Professor Mulugeta, for a very erudite presentation. I don't intend to sum up what you have said and open another lecture here. All I want to say is I would like to refer to your last slide. The cradle of mankind, I liked it very much. And the kind of the rifts which are taking place on a metaphorical manner, the rifts which are taking place in the mankind, in the minds, are as tsunami producing as the rifts which are also on the geological kind of landscape. So that's one part. But the other interesting aspect is that in the Egyptian area on the entire Nile, you have the blue Nile towards your side, I guess on the Lake Tana, is that right? So that's
right.
Yeah. But the entire civilization, some of the oldest civilization of mankind, it's all there on the Nile itself, and in Egypt, one had seen that. So the interesting point is that when the pyramids came up in Egypt, that's essentially because the floods were visiting Niles, and people for 4 months they had nothing to do, so they would be brought to Cairo, and the emperor or the pharaohs used to use them for the building up of the pyramid. We don't see such huge pyramids in Ethiopia area, although I think we have heard of some pyramids also in Sudan, in the Nubian area, but I don't know if you have some smaller pyramids also over there in Ethiopia. Do you have that?
We have obelisks. We call them stele or obelisks in the northern part of Ethiopia, in a town called Aksum. Those are 2,000 years old, not as old as the 4,000 or 3,000 in the pyramids,
the Egyptian
but not the
ones.
pyramids. These are, but they are very magnificent in a sense, like 20, 30 meter tall obelisks carved from a single rock, not pieces. So we have those.
Wonderful.
May I add a few things? Actually, there was civilization here in this part of northern part of Ethiopia, where this Aksum was the capital of the kingdom. Aksum, where this stele Dr. Mulugeta is speaking about, I have seen those stele, huge, massive, 27. Am I right? You mentioned 27 meter high. 27 meter high, from a single piece of rock carved out of. I have got the photographs. Sometime later, I can show them later.
Okay, but I don't know if they are actually pyramidal in structure.
No. It is like a tower. It's like a tower. It's like a tower.
The reason I'm trying to say, I just want to wind up that part. The reason I'm trying to say, everybody would think that where did the pyramid, the geometry of the pyramid, how did it occur to mankind 4,500 years? And then if you go to Corona or the Kona area, which is another 100 kilometers north of Cairo, which is another 1,000 years old. So 5,500 years old. pyramids, and the pyramidal structure itself is so complex. How did it occur to mankind to build such a structure? And people say that it happened essentially because the early man perhaps saw the sun rays filtering through the leaves and the trees, and when they come through, they form some kind of the trapezium, and the pyramids actually came up also. So what Professor Mulugeta has today spoken about, you have combined geology, you have combined anthropology, you have put them all together, and that clearly shows that the knowledge today, it is, if you want to understand it in its entirety, then one has to actually get into many of these in order to put the threads together. So thank you very much for opening up our minds, opening up our eyes into many things that we never knew. So thanks very much. And with that, I conclude my part. Thanks.
Thank you. Thank you,
And
sir.
one other thing before I
just
forget, which is very formal. It has been a tradition that through the DLS, the Distinguished Lecture Series, whoever speaks gets trapped. I say trapped once again to emphasize the word trapped, because you become a part of our fraternity, which we call the of geoscientists and allied technologists, which means you will also become our member, and somebody will send to you a formal application form. And we would like to see SGAT also showing its flag in your university and through you elsewhere in Case Western and elsewhere also. So that
would be my pleasure. I would be happy.
Thank
you.
Thank
you. Dr. Mulugeta, now I think you can withdraw your presentation. We can see you before we
No, we are able to see, but small figures only, but we can see him in all his grandeur. Shall we?
Yeah.
Dr. Mulugeta.
Thank you so much again to all of you.
No, just hold on, Sujit. I think he's withdrawing the the sharing of the slides, that he has to stop so that we can see him in the center, and so then Sujit can thank him more adequately.
We are able to see him, sir.
No, that's correct. That is correct. But he is now. You simply have to.
What am I doing?
Stop
Okay.
the sharing. Yes.
Okay.
That's it.
Yeah, this better.
Yeah.
Yeah. Now I would request our General Secretary, Mr. A.B. Panigrahi, to offer formal vote of thanks. Mr. Panigrahi, please.
Thank you, Mr. Sujit. An excellent presentation.
Thank you.
It was full of knowledge. It gave us insight into the topic and also revealed very interesting facets. And we thank you from our core of the heart, Dr. Professor Mulugeta, for the very interesting presentation which you made today. And I request everybody to give a big hand clap.
Right. So now you can open your.
Right.
Thank you so much.
Thank you very much.
And
Right.
We
are extremely thankful.
He becomes a member, I have already said. Yes.
Right. And thank you very much for the commitment to become a member of also of SGAT. We are also thankful to our president, Professor Omkarnath Mahanti, who is always inspirational and motivating us to complete the DLS lecture on time. So thank you very much, sir.
Thank you.
And we are also our sincere thanks to the international attendees, particularly brother of Professor Mulugeta, who have joined
and
in spite
faculty
of different time zones.
And some faculty members from Addis Ababa University are there.
Thank you very much. Thank you, sir.
Thanks to all international attendees. Our sincere thanks to all international attendees who have joined us in spite of in different time zones. So we do not know what time zones they may be there. And we are also thankful to all the persons who have joined from our country, India, along with our SGT members who have made this program a very lively one, along with the question and answer session. And we are also, my heartiest thanks to our Distinguished Lecture Series 5 group members who have taken all the pains, led by Sri Girija Prasad Mahapatra.
Dr. Farooq and
lecture
Mr.
from
Sujit Mohanty.
Professor Mulugeta. Yes, and my sincere thanks also are due to Dr. Farooq for moderating the question and answer session, and also he gave a special inputs also. It is understood that he has deep knowledge about Ethiopia, where he has also worked
He brought
years.
in Dr. Mulugeta for this lecture. It was he who brought him in. Yes.
He was
Right.
okay. Right. Thank you.
Yes.
Thank you, Dr. Farooq. And last but
Welcome.
not the least, our anchor, Sri SK Mohanty, and our event software assistant, Sri Devasis Parida, and all those who have directly or indirectly helped to make this program a success. Thank you, everybody, and good night for our Indian members, and good evening for the Ethiopians, and I do not know other parts of the world, whether
Yes,
it is
sir.
good evening or
Good
good morning
morning,
or
Good
good
day
morning.
for the USA.
For some it may be good morning. From USA it is good morning. And
Most
with
important,
this,
stay
with the kind
safe.
permission of the President,
Stay safe. Most important, stay safe, because I think the COVID is now also threatening in some parts of Africa.
yes, for the
Right.
world, right.
It's true.
So that's
Yeah.
extremely important that
And
you take
thank you
care
very much once again, everybody. And with the kind permission of the President, we take the program as closed.
Okay. Namaskar and good night.
Right,
Thank you
sir.
so much.
Namaskar and good night.
Thank you, everyone.
Good evening.
Thank you.
Bye bye.
Right, thank you.
Bye bye.
Thank you
Bye
for
bye.
having
Bye
me.
bye, Dr. Mulugeta.
Thank you
We'll
again.
meet very soon. Again.
Yes.
Sure. I will see you soon.
Sure.